Okay, so adding and subtracting rational expressions. The main thing is you need a common denominator, so factor to find common denominators. So right here, I'm going to factor the bottom part. This is going to be x minus 3. It's a difference of perfect squares, x plus 3. Okay, now this one's already factored, so I have that. So what is a common denominator between all of these? Well, if you get stuck, like for example, if you're trying to find the common denominator between something that has a seventh as a denominator and an eighth, you would just multiply those two and get 56. So the same process applies here. Just multiply everything together, and guess what? That is your common denominator. Like Occam's razor, sometimes the easiest method is also the best. Okay, so what I need to multiply this top and bottom by is 5x times x plus 4. Okay, and then I have everything down there. So I'm just, since I don't have much room, I'm just going to replace that with CD and CD to get the common denominator. Now this is missing the 2, the fraction on 2 has the x plus 4, but it's missing the x minus 3 and the x plus 3. So up top, I'm going to actually have that as 2 parentheses x squared minus 9. And you could just leave it as 9 right there. Okay? Alright, now I know I said before don't simplify or contract everything, leave it in this factored form, but sometimes for the space of the size of the screen, I just go ahead and say do it. Okay, now for the top part I'm going to distribute, and I should get 5x squared plus 20x. Okay, and then this part right here is going to be 2x squared minus 18. Okay, and I'm going to be minusing this. So this will be in parentheses because I'm minusing the whole thing. Okay, all right, and just remember, adding and subtracting, you still have to pay attention to the operation. Okay, all right, now over here I can write out the common denominator, which will be x minus 3, x plus 3, x plus 4, like that. And then I'm going to subtract like terms on top. So that means subtracting the 5x squared minus the 2x squared, which is going to be 3x squared. Okay, I can't subtract anything from the 20x, so that stays as 20x. But subtracting negative 18 becomes positive 18. Okay. All right, now if you'd like to factor the top part, you would have to do the AC method. So let me check it, and I'll come back with the factored. By quickly checking my quadratic equation, well, just by finding it crossing the x-axis, I see that I cannot factor this. So I just leave it as is, and there's my simplified form because I can't factor it anymore. Okay, now complex fractions, I understand they might be scary for some people. But in reality, if you just take it one step at a time, it's a really easy process. So when I look at a complex fraction, I just look at the bottom or the top first and then simplify that and then just work from there. Okay? All right, so for this one, okay, I have 1 minus 1 over 4x. So the common denominator up top is going to be equal to 4x. Okay? So I'm missing a 4x from here, so this is like a 1 over 1. And so to change it to its proper form, I need 4x over 4x. Okay, so this becomes 4x minus 1 over 4x. Okay. All right, now this bottom part, the common denominator is going to be x. So I don't need a common denominator between the two just yet. Okay, so the common denominator is just going to be x. Okay, and this is 2 over 1. And if I need it to be an x on the bottom, I need 2x over x. Okay, so that becomes, on the bottom, that's 2x minus 3. And this is going to be over x. Okay. Now I cannot divide these two, but I can multiply by the reciprocal. So once again, I am still applying knowledge from what I've used before to this. And so this becomes x, and this becomes 2x minus 3. Okay. Now, as you can see, the x's, these will end up simplifying to 1s. Okay, I can't factor these, so I just leave those alone. Okay, so what I'm left with is up top is a 4x minus 1 over 4 parentheses 2x minus 3 on the bottom. And obviously I have to have my fraction bar in between. Now if you notice, I did end up canceling something out. So on this one I will have to write out my my removable discontinuity. So x cannot be 0. Okay, so as long as I understand that, I should be fine. Now obviously you understand that it's also going to be x cannot be 3/2, but that's kind of given. And then this one up here, I didn't talk about the removable discontinuities because there was nothing to simplify, nothing to really work with here. Okay, and so I just left it as x cannot be 3, -3, and -4. Okay. All right, so this is how you add and subtract rational expressions. Complex fractions, just deal with it one fraction at a time and then multiply by the reciprocal and you'll be all set. Okay, you guys have a wonderful day. Bye.